So in the plurality with elimination method, voters fill out a preference ballot once, and if then we conduct the election in rounds. Okay, in round 1, we count up all the first place votes, and if anyone has a majority, what was a majority? More than half. More than half. Yep. If any candidate has a majority, they have won and it's over. Okay, so that's sort of the easiest scenario in plurality with elimination. If someone has a majority, they win, done, nothing else to do. What? What? Just more than half. If you have more than half, doesn't matter how much over you are, more than half is a majority. All right, so, but if that's not the case, if you count up all the first place votes and no one has a majority yet, no one has more than half the votes, then you move to round 2. You eliminate the candidate that has the fewest first place votes. You just throw them out. You say, you seem to be the least favorite. We're going to redo the election without you. Okay. And then when you throw that person out, it moves all the other candidates. Any candidate that was ranked below them gets moved up a spot. Okay. And then we recount the first place votes. If someone has a majority, we're done. If not, we move to round 3 and eliminate the candidate with the fewest first place votes and recount the first place votes and see if someone has a majority. All right, we keep doing this until someone has a majority of the votes. So this method, it's used in Australia, Ireland, San Francisco, some student governments, and some various awards. We'll do an example. I think it'll be much clearer. So we're going to use the plurality with elimination method on this same math club election that we did last class. So if you remember when we did the plurality method, A won, and when we did board account, who won? B? I think. Yeah, B won with board account. So now we're going to do the same election with plurality with elimination. So round 1, we just count up first place votes. So we say A has how many? 14. B has 4. C has 11. These 10 plus this one ballot over here. Okay. And then D has 8. Okay. So far this looks just like the plurality method, right? That's why we call it plurality with elimination. Now, how many people voted in this election? 37 voters, which means how many do we need for a majority? 19. Half of 37 is 18.5, but you need more than half to get a majority, so 19 would work. 19 is the fewest you could get for a majority. Okay, does anyone have a majority yet? No. So that means that we eliminate the candidate with the fewest first place votes, and that would be B. Okay, so B is going to get thrown out. So then when we go back to our preference schedule, B, these 4 people voted for B, right? But now we ruled B out. B is never going to win because that too few people want B. But these 4 people, we can tell from their ballot who their second choice is. So if they can't have B as the winner, who would they have picked? D. We can tell because D is ranked second on their ballots. So that means those 4 votes that were for B are now going to go to D. Okay. So we recount the first place votes now that candidate B has been eliminated, and we say, okay, now A still has 14. B is gone. C still has 11. And D has the 8 it had before, plus the 4 votes that used to be B's, right? So plus 4, making 12. Does that make sense? Yep. Okay. Does anyone have a majority? No. No one has 19 yet. So now we eliminate the candidate that has the fewest in this round, which would be C. Okay, so we're going to get rid of C. And then we recount the votes between A and D. Right? So A and D. So we have to go back to our ballots and decide those 11 votes that were for C, we have to decide who they're going to go to now. So that's this column and this column had the C in first place. So these 10 people would have chosen B, right? But B's gone. We eliminated them in the first round. So their votes are going to have to go to D. Okay, so D had 12 in the last round, and then we're going to give them these 10. And A had 14 in the last round. Right, so we look over here, and this one person who had C in first place, their next place candidate is D, so we give that one vote to D also. And A ends up with 14 plus 0, which is 14, and D ends up with 23. So D wins the election because they now have a majority. They have more than 19. All right, so let's say I wanted to do the complete ranking, first through fourth. Well, who wins? D. So D is going to get first. Who do you think we should give second place to? A, because they were the last candidate still standing before we determined a winner, right? And then who should get third place? C, because they were eliminated second, yeah. And then last place should go to B, because that was the first candidate eliminated. D, A, C, B. All right, so let's go back and write down the winner from our three methods. Plurality was A in this election, and Borda was B. And now we just learned a new method, plurality with elimination, and the winner is D. That is pretty crazy. Yeah. All right, so our fourth and final election method is called the method of pairwise comparisons. It's also sometimes called Copeland's method. So in this method, each voter fills out a preference ballot just once. And as the name suggests, you compare every pair of candidates. So every set of two possible candidates, we compare them head to head. So for each head-to-head comparison, the winning candidate gets a point and the losing candidate gets 0 points. And if they tie, we give each candidate half a point. All of the points are tallied up, and the candidate with the most points is the winner. So here's our math club preference schedule, yet again. How many voters are there in total? 37, right. Okay, so we want to determine the math club president using the method of pairwise comparisons. So we start by listing all of the possible matchups, the face-to-face, head-to-head matchups. So we're going to match candidate A against every other possible candidate. So we can do A versus B, A versus C, and A versus D. So that's A matched against everybody else, right? And now I'm going to do B's matchups. So now I'm going to do B versus, I already have B versus A written over here. Right? So B versus B, that doesn't make any sense. So I move to B versus C and B versus D. And then I do C's matchups. C versus, I already have C versus A written here, and I already have C versus B written here. So I just do C versus D. And then D's are all done. D has been matched against everyone already. C, C, B, and A. Yep. All right, so these are all the possible head-to-head matchups. Everyone is matched against everyone else. There are 6 matchups when you have 4 candidates. So now we use the preference schedule to force every single voter has to make a choice between A and B. Right? So we look at these 14 voters. If we forced them to choose and we said, listen, you 14, you have to pick between A and B, who's the better choice? Who would they pick? A, because they have A ranked above B. Okay, so we give 14 votes to A. All right, how about the next 10 voters? If we force them to choose between A and B, who would they pick? B, because they have B ranked above A. So we're not just counting first place votes here, we're forcing everyone to choose between A and B. So these 10 people, we give those votes to B. And in fact, everyone else would choose B because they all have A ranked last. So every other column is going to go to B. So we've got B. Yes. So we're forcing the people who voted like this, we know that if we forced them to pick between B and A, we know they'd pick B because they have B ranked higher. So we give all those votes to B. All right, so then we add them up. A gets 14 and B gets all the rest, 18, 22, 23. So we say B wins that matchup. And when you're done tallying the votes, 14 and 23 adds to what? 37. You should always get the total number of votes when you add these. It's just a little check to make sure you did it right. All right, let's look at A versus C. These 14 people, who would they choose? A, so we give 14 votes there. 10, who would they choose? C, because they have C ranked above A. In fact, everyone will choose C because everyone else has A ranked last. So we give the 23 remaining votes to C. C wins that matchup. All right, A versus D, it's going to, again, be 14 to 23. We give that to D. B versus C. For the first 14, if we force them to choose between B and C, who would they pick? B, because they've got B ranked higher than C. So we know that they prefer B over C. So we give 14 votes to B. The next 10, who would they choose, B or C? C, so we do 10 to C. And then the next 8, B or C? C, so we put 8 under C. And these 4, they would choose B because they have B ranked above C. So we put 4 votes here. And then the last one would choose C. So this is 18 to 19. C wins that matchup. And 18 plus 19 adds to 37. Okay. All right, you guys do B versus D and C versus D. Compare with each other. Make sure you can figure out the matchups. What do you get for the total for B? How many voters would prefer B?
28.
28, and that means D would get 9, so B wins that matchup. And then C versus D, what do you come up with?
25 for C, 12 for D.
Everyone agrees? 25 to 12. Okay, so C wins that one. All right, then we count up how many matchups each candidate won. All right. How many matchups each how many times did I circle B up there? Twice. Okay, so now we tally the scores for each of the matchups. So B, oh, sorry, I'm doing this in the wrong spot. Oh, man. Okay, so once we've got all the scores tallied, we're at step 6 here. Okay.
I knew we were going somewhere.
Yeah, so we did a bunch of it all at once. Okay, so once we've got all the scores tallied, it's time to award points based on the winners of the matchups. So for each win that a candidate gets, you give them a point. If it happens to be that they tied, which is impossible in this case because there were 37 voters, but if it happened to be that they tied, you'd give each one half a point. All right. So for pairwise comparisons, let's look A. How many matchups did A win? 0. Okay, so A was 0 points. And then B, how many matchups did B win? 2, so B gets 2 points. C, 1, 2, 3 matchups for C, and D gets 1. So C is 3, D gets 1. And a quick check, these should add up to 6 because there were 6 head-to-head matchups. So there should be 6 points to give out. These do add up to 6, so we're good. All right, so who's the winner?
C.
C is the winner. What's the complete ranking? C, B, D, A. C is the winner with the most points.
So,
Yes.
so we're not adding any extra to these, we're just going. I thought you meant that we had to give, like, say if it was 2, they get so many extra.
Oh, no, no, no. So these voting tallies are just to determine who wins the matchup. And then to determine the winner of the election, it's just whoever won the most matchups.
And if it's a tie, then you strip the out.
Yeah, like let's say you know, B and D tied, let's just make it up 10 to 10. Instead of giving 1 point to B or 1 point to D, you give half a point to each.
So you would circle both of them for that matchup because they tied.
Yeah, that's what I do. Yeah. All right, so the downside, one downside of the method of pairwise comparisons is that it can lead to a lot of ties. Sometimes many candidates can tie for the most points. And every new candidate adds a lot of comparisons that we have to do. So let's think about how many comparisons are required. We already know for 4 candidates there are 6 comparisons because we just did an example. How about if there are 3 candidates, like A, B, and C? How many matchups would there be?
4.
Let's write them out. We do A against everybody else, A against B, and A against C. Then we'll do B's matchups, but B's already against A. So B against C, and then C is already matched against the other 2. So 3. And then 6 for 4. How about 10 candidates? A lot more than 12. Let's write it. So we would have A, B, C, D, E, F, G, H, I, and J, right? So we would do A versus B, A versus C, A, D, A, E, E, F, G, H, I, J. So that's A against everybody else, right? And how many matchups is that? 9, because you don't do A versus A, right? So this is 9 matchups. Okay. And then when I do B's, right, I already did B against A, which means that I start with B against C. What's wrong with this thing? Yeah, I gotta do B against C, B, D, E, F, G, H, I, J. How many is that? 8. 1, 2, 3, 4, 5, 6, 7, 8.
Yeah. Okay.
And then when I do C's matchups, I've already done against B and against A, so I start with D. And I do E, F, G, H, I, J, which is 7 matchups. So then I can say, oh, well, it's 9, 8, 7. Then when I do D's, I'm going to get 6. And when I do E, I'm going to get 5, 3, 2, 1. Yes, so I'm going to have to add 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. 9. Is it 45? Somebody did it. Okay, thank you. 45 matchups. That would take a long time to do by hand. So this would be a nice method when you have a computer or for a smaller election, yeah. For N candidates, you end up having to add up all the numbers from 1 to what? N minus 1, yeah, because for 10 candidates, we had to add up 1 plus 2 plus 3, and we stopped at 9 when there were 10 candidates, because there's no A versus A, right? So if you're adding N candidates, if you have N candidates, you would add 1 plus 2 plus 3, and you would stop 1 before N. So if there are 15 candidates, you do 1 plus 2 plus 3 plus 4 up to plus 14. Does that make sense?
Unfortunately.
Let's talk about.
We'll never be doing those like for homework or anything.
You might.
Like maybe 6, but not crazy.
Oh, I won't ask. No, I won't ask you to actually do the method for 10 candidates.
Okay, yeah,
no,
yeah.
But there might be a homework question. How many matchups are there for 25 candidates?
Gotcha.
So let's do that. How many matchups or 25 candidates. Yeah, we'd have to do 1 plus 2 plus 3 plus 23 plus 24, right? You'd stop one short of the 25. And you'd say, I don't want to type that all into my calculator. There's a fun little method to do this, a fun little trick. We say, well, this has got to equal something. I just don't know what it is. Call it X. And there's a story that goes with this method about this really famous mathematician named Gauss. And that he was a genius, like maybe one of the most important and famous mathematicians like in history. And the story goes that when he was in elementary school, he was such a troublemaker that his teacher told him to go sit in the corner and add up all the numbers from 1 to 1,000. And he did it in like 30 seconds, just frustrating his teacher further. And this is the method that he used. Okay. So he said, well, if I write them all out 1 to 24, it's got to equal something. And because you can do addition in any order you want, I could write them out backwards to forwards, right? I could write this list out backwards and say 24 plus 23 plus 22 plus 2 plus 1 has to equal the same thing, right?
Yep.
All right, so if I take these two equations and add them together, what's 1 plus 24? 25. What's 2 plus 23? 25. What's 3 plus 22? 25 plus 23 plus 2 is 25. 24 plus 1 is 25. And x plus x is?
Still weird. Next to the second,
2x. X squared means x times x, right? So x plus x is 2x. All right. So I'm adding up a bunch of 25s. Repeated addition. What mathematical operation is repeated addition? I heard somebody say multiplication, yeah. So I'm adding 25 to itself how many times here?
25.
No, 24.
Yeah,
Look at,
that's right.
this is 1. You can look at the index on the top, right? 1, 2, 3, 23, 24 times I added things together and got 25. So I have 24 of these.
Yep.
So 25 plus 25, 24 times is 25 times 24. Then just divide both sides by 2. So we get x is 25 times 24 divided by 2. $300. So there would be 300 head-to-head matchups when you have 25 candidates. Yeah, right. He was kind of a genius. All right, if you're interested in seeing a real-life preference ballot, this is a ballot from Burlington, Vermont, and it's an actual ballot from their mayoral election. But Burlington used plurality with elimination for a couple of elections, but the city ultimately decided to go back to the regular old plurality method. So this is how they had it ranked. So these were all the candidates, and you would put your first candidate. I like him best, and I like this person second best, and you fill it out like that. So it would take all your preferences into account, and it used plurality with elimination. Yeah. All right, so before I have you work on the group activity where you're going to practice using plurality with elimination and pairwise comparisons, the two methods we learned today, first I'm going to hand out the ballots that you emailed me, and you can fill them out for each other. And then while you're working, I'll divvy them up and give you your own ballots.